Hello everyone, this is the problem that you've been waiting for, hopefully. So we have f of x equals x cubed plus ax, and we're going to find the inverse of this function. This is a cubic function, a special form of a cubic function, and we're going to find the inverse. But we also need to talk about, does this function always have an inverse? Now this problem has been inspired by something that I found on the internet. Somebody shared a collection of problems that they made, and then I can't remember what it is, but if I find the link, I'll definitely share with you, so you can look at the other problems. So let's go ahead and talk about when this function has an inverse, or if it always has an inverse. First of all, we are going to talk about cubic functions. So cubic functions, as you know, can curve, right? So for example, if I have a cubic function that has like these intercepts, obviously it's just gonna turn, and it's going to curve something like this, and it is going to fail the horizontal line test, which means that for different x values we're going to have the same y value, which means you're not going to be able to find the inverse of this function. At least it's not going to be a single function. You can divide it up into different intervals, but that's not what we're looking for. And the problem, the question on that thing that I found was for which a values does this function have an inverse? That's what we're going to explore first. I'll show you some samples, and then once we find out, we'll start finding the inverse of this function, which is going to be lots of fun, by the way, because we're going to be using Cardano's formula, but with lots of variables, so it's going to be crazy, sort of. That's why I call this a crazy idea, and share your thoughts on how crazy you find this. But anyways, what was I saying? So we're going to solve this, and at the end I'm going to show you a graph which is really, really cool. Okay, great. So let's go ahead and find out or explore when this function has an inverse, or does it ever have an inverse, right? That could be a possible answer. Well, since a cubic function sometimes curves, then we don't always have an inverse. So if you have a cubic function with real coefficients, you got to recognize it must have at least one real solution. Let's do some calculus, shall we? All right, great. So suppose f of x is equal to x cubed plus ax for some real number a. All right, great. So we're going to differentiate this function, and when we do, we get 3x squared plus a, and I'm going to set it equal to 0 and try to solve for x. Now notice that if a is positive, this function, this equation has no real solutions, right? Which is something good for our purposes. But if a is negative, then 3x squared equals negative a has two solutions, which means they're different, right? For example, suppose we have f of x equals x cubed minus 3x. And again, I'm going to show you the graph of these. The derivative is going to be 3x squared minus 3, set it equal to 0, you're going to get two x values. So f is going to curve in this case. All right, turn around. That's what I mean by curving. Of course, there are always curves, but you get the idea, hopefully. Now, if a is positive, then f prime, which is 3x squared plus a, is going to be positive, because 3x squared cannot be negative. You're adding a positive quantity like 3x squared plus 1. That can never be 0, right? Which means f is always increasing, which means it is bijective. Yay! If f is bijective, we can find a unique inverse for f. Awesome. So let's go ahead and find the inverse for a is greater than 0. But before that, let's go ahead and take a look at some graphs. So I'll show you two samples for a equals negative 3. This is the graph. As you can see, it is going to fail the horizontal line test. Therefore, it's not going to have a unique inverse. When a is negative, we're running into a problem. But when a is positive, like a equals 3, then you're going to have a single inverse, because our function is always going to be increasing. And we looked at it from a derivative perspective, right? Okay, great. Now let's go ahead and start finding the inverse. So if a is positive, right, we want a to be positive, Now we're going to find the not the derivative, we're going to find the inverse. So to find the inverse, let's go ahead and set f of x, which is x cubed plus ax, equal to y. And don't ask why, because that's how you find the inverse. Now you can go ahead and solve for x to find the inverse. And when you do, since f of x equals y, x is going to equal f inverse of y. And once we find f inverse of y, we're going to replace y with x, so on and so forth. Hopefully you get the idea. But some people switch x and y first, and then they solve for y. It's the same thing. So now we're going to use Cardano's formula, which is lots of fun. So let's remember the following identity. We have m plus n, quantity cubed equals m cubed plus n cubed plus 3mn multiplied by m plus n. I'm going to subtract this from both sides so that I can turn this into a cubic. And I want to leave m cubed plus n cubed on the right hand side because that's what my cubic is going to look like. So here we do this, like, this is really neat. We're going to replace m plus n with x. This is the trick for solving cubic equations. Not too hard, just experiment. So from here we get x cubed plus 3mnx equals m cubed plus n cubed. Now if you solve for x, that's what our goal is. But our equation is slightly different, right? So let's go ahead and write it down here. X cubed plus ax equals y. And we're trying to solve for x, so we have a cubic equation. Now if you compare these two equations, you're going to notice that I can correspond negative 3mn with a, which indicates mn equals negative a over 3. Awesome. And then by comparing the constants on the one on the right hand side, because y is a constant, because we're solving for x. All right, I should slow down maybe. M cubed plus n cubed equals y. Now we have a system, but let's go ahead and cube both sides here so we can write our system like this. And now by solving the system, we're going to be able to find the x value. That's going to give us a single value, but obviously you can find the other values. We can also talk about that. Okay, great. This brings us to the graph, but don't worry, we're going to skip those and continue with the work. So from here we can do the following. Let me go ahead and copy that here, and I can actually, well, I can probably rewrite it. So m cubed plus n cubed, remember, is equal to y, and m cubed n cubed is equal to negative a cubed over 27. So that's my system. And in this system, this is quadratic, by the way. It looks cubic, but it's quadratic. I can go ahead and isolate n cubed, write it as y minus m cubed, and then go ahead and substitute that into the second one. M cubed multiplied by y minus m cubed equals negative a cubed over 27. So bear with me because this is going to be a long video. We're going to have a lot of variables to go through. So at this point, I want to replace m cubed with another variable. How about z, to z or not to z? Okay, this gives us z times y minus z equals negative a cubed over 27. Now, these are basically, a is a parameter here, and it's really nice to work with parameters. And by the way, in the near future, I'm going to do a video on a equation with parameters. But anyways, parameters are fun because, first of all, you can't really guess the solution here. That's going to be extremely hard. And also, second of all, it gives you, it kind of makes you think. So I really like those problems. Anyways, let's go ahead and distribute z. I should probably write it as yz, right? Because it's in z. Minus z squared equals negative a cubed over 27. Let's multiply both sides by 27. And then put everything on the right-hand side so we can get our nice quadratic in z, all right? So since our equation is in z, notice that negative 27y is just going to be a coefficient, right? All right, great. So this is our quadratic, and how do you solve the quadratic equation? Okay, thinking, quadratic formula, awesome. Let's go ahead and use the quadratic formula here. So we can write z as negative b, which is 27y, plus minus the square root of b squared, which is 729y squared, plus minus, or well, plus minus, not plus minus, minus 4ac. But if you multiply minus 4 times a times c, you get a positive term. Plus 4 times 27 is 108. So that gives you 27 times 4, which is 108, a cubed. Okay, great. I was able to do that. Divided by 2 times 27, which is 54. Awesome. Now, we can simplify this because 729 and 108 are both divisible by 9. So I can divide inside by 9 and take it out as a 3. And to keep a long story short, can I skip this part? It's really easy. You can do that. I'm going to get a simpler version, which is 9y plus minus the square root of 81y squared plus 12a cubed. And that is going to be divided by 18 because I divided everything by 3. But inside the radical, it's division by 9. Awesome. Z, remember, is equal to m cubed. Yay! We found the value of m almost. And n cubed is equal to y minus m cubed. By the way, m cubed and n cubed are interchangeable, so it doesn't really matter which one is which. But anyways, if you subtract y minus this, can I just tell you what it is? I hope you don't mind. It is going to be, oh, by the way, the one thing that I forgot to say, let's go ahead and go with the plus sign here because that's going to be confusing. So suppose m cubed takes the plus sign, then n cubed is going to take the minus sign. So it's going to look like this. Okay, I'll do it. So it's going to be y minus 9y plus square root of 81y squared plus 12a cubed all over 18. And 18y minus 9y is just going to give you 9y. So n cubed is going to be 9y minus 81y squared plus 12a cubed over 18. Awesome. So m cubed and n cubed are just going to be conjugates like that. So to find them, we have to cube root both sides. So let's go ahead and cube root both sides on each. M is going to be the cube root of 9y plus the square root of 81y squared plus 12a cubed. I hope you're still with me on this craziness. And n is going to be the cube root of the same thing pretty much, except there's going to be a minus sign in between. But under the radical, it's the same idea. Great. So I got the m and n values, so we can go ahead and put it together. Remember, x is equal to m plus n, and our goal was to solve for x. And here you go, x in its glory. X is equal to cube root of 9y plus the square root of 81y squared plus 12a cubed, and all of that is divided by 18 under the radical sign, and then plus the cube root of 9y minus the square root of 81y squared minus, or not, no, that's not a minus sign, come on, divided by 18. You get the idea. And yes, this is x. Phew, finally we got x value. And remember, x is equal to f inverse of y, but you're looking for f inverse of x. Therefore, in this expression, just replace x with y with x, and don't worry about anything else because that is going to be confusing. So to keep a long story short, sorry I kept it too long, but f inverse is going to be the cube root of 9x plus the square root of 81x squared plus 12a cubed divided by 18 plus the cube root of 9x minus the square root of 81x squared minus, plus, I don't know why I keep saying minus, and that. There you go. That is going to be f inverse of x. Wow, that's crazy. Okay, now let's go ahead and check the graph. So that's my function, and here's the graph. Isn't that crazy? I hope you find this crazy too. Please let me know. F of x is given, and g of x is just f inverse. So first of all, I solved this problem, and then I checked on Desmos, and I found like, yay, these functions are symmetrical with respect to the diagonal y equals x. And that is the link, but don't worry, I will also include that in the down below somewhere. I don't know. If I forget, please let me know in the comment section so that I can give you the link, but it's not too bad. You know, you can just type it up as well. And this brings us to the end of this crazy idea. Thank you for watching. I hope you enjoyed it. Don't forget to comment, like, and subscribe. Tomorrow I'll see you with another video. Until then, be safe, take care, and bye-bye.